problems on bilinear transformation. Yes, first problem. Find the bilinear transformation which map the points z is equal to 1, I minus 1 into w is equal to w is equal to I 0 minus I. Under this transformation, find the images of mod z less than 1. Let us see the solution. Let w is equal to az plus b divided by cz plus d be the required bilinear transformation. Now we have to substitute in this bilinear transformation formula. So I take first value z is equal to 1, w is equal to I. So wherever w is there we have to substitute I. That is equal to z value is 1. So a plus b divided by c plus d. That implies a plus b is equal to ci plus di. I call this one as equation 1. Next, z is equal to I, w is equal to 0. Now 0 is equal to wherever z is there we have to substitute I. ai plus b divided by ci plus d. That implies ai plus b is equal to 0. Call this one as equation 2. Next, z is equal to minus 1, w is equal to minus I. That implies minus I is equal to minus a plus b divided by minus c plus d. That implies minus a plus b is equal to multiply ci minus di. Call this one as equation 3. In the next, we have to solve for a, b, c, d. So here after finding out, now adding 1 plus 3. Our equation 1 is a plus b, shift ci plus di to the left side. So we get ci minus di is equal to 0. Next, minus a plus b minus ci plus di. This is the equation 3. Now minus a plus a will get cancelled, di will get cancelled. 2b minus 2ci. This implies b minus ci is equal to 0. Next, equation 2 and equation 4, writing in the form here I will write aia plus 1b plus missing term I will write 0c is equal to 0. Next equation, call this one as equation 4. So equation 4, here a is missing, so I write 0a plus 1b minus I into c is equal to 0. Now we have to apply the rule of cross multiplication. Rule of cross multiplication. We have a divided by determinant of these two we have to see. One coefficient 0, 1 minus I, like that. Rule of cross multiplication. We have a divided by determinant of 1, 0, 1 minus I, that is equal to minus b divided by coefficients of b. So what we have to write here, I 0, 0 minus I, that is equal to c divided by I 1, 0, 1. Next, a divided by minus I minus b divided by minus I square, that is equal to c divided by I. We call this one as a k. Therefore, a is equal to minus I into k, b is equal to minus k because I square value is minus 1, c is equal to I into k. Substitute in equation 1. Substitute in equation 1. We get, wherever a is there in equation 1, ik, b value is minus k, c value is minus ik into I minus di is equal to 0. That implies here, first I will write minus ik minus k, I into I square value is minus 1, minus into minus plus k minus di is equal to 0. Is equal to 0. So kk will get cancelled. We get minus ik is equal to di. That implies I will get cancelled. D is equal to minus k. Next, Here, next what we have to write, we have to substitute all this one in the bilinear transformation formula, that is W is equal to AZ plus B divided by CZ plus D. A value is minus IK into Z, B value is minus K, C value is IK into Z minus K. Now I will take K as a common term, so I get Iz plus 1 divided by, here also minus K, so here I get minus Iz plus 1, K will get cancelled. Now 1 plus Iz divided by 1 minus Iz is the required bilinear transformation. Now, the next they have given to find the image. So, right, let us find the image of mod z is less than 1. So, I write the bilinear transformation is W is equal to 1 plus Iz divided by 1 minus Iz. Cross multiply. 1 plus Iz is equal to W into 1 minus Iz. Now 1 plus Iz I will write as it is. Here I will multiply with the W. W minus Wiz. That implies Wiz, I shift to the left side, I take 1 to the right side. So I will get W minus 1. Here I take Z as a common or Iz as a common. I will get 1 plus W is equal to W minus 1. Z is equal to Iz or Zi is equal to W minus 1 divided by W plus 1. So Z is equal to 1 by I into W minus 1 divided by W plus 1. So after writing this, we have to see the image. They have given the image mod Z is less than 1. So we can write here mod Z is less than 1. That implies apply mod for the Z term. Mod I, mod of 1 minus W divided by 1 by W, 1 plus W is equal, less than 1. Now, squaring on both sides. Squaring on both sides means mod I square. The value is 1. So, mod of 1 minus W whole square is less than mod of 1 plus W whole square. Now, we know that W is U plus IV whole square less than mod of 1 plus U plus IV whole square. Now, I will group the real with the real term. 1 minus U again minus IV whole square less than mod of 1 plus U plus 1 minus V whole square. Next, step here. For this one, what we have to do? We have to remove the mod. So it becomes 1 minus U minus, here we have to split using A plus B. So here I square. Squaring means I square means here plus minus 1, minus into minus plus v square less than, here also square, 1 plus u whole square. Again, when we remove mod, all negative term will convert into positive term. So here plus v square. Now split this, 1 plus u square minus 2u plus v square less than 1 plus u square plus 2u plus v square. So here 1 plus u square, 1 plus u square, v square will get cancelled. Here we get minus 2u less than 2u. I shift this minus 2u to the right side. So 0 less than 2u plus 2u. So 0 less than 4 into u, or we can write 4u is greater than 0. That implies u is greater than 0. Therefore, u greater than 0 is the image of mod z less than 1. This is the solution.